Hi, everyone. Thank you for joining us for our next live stream. I'll be your producer for this session. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you for joining.
Welcome, everyone. Welcome to our Microsoft IQ Deep Dive with Python live stream series. This is our final session in the series. We already covered Founder IQ and Work IQ earlier this week. And now for our final session, we're focused on Fabric IQ. If you missed any of the earlier sessions, you can go back and rewatch them. Everything's available, the videos, the slides, the code, and we can share those links in the chat. So you can catch up at any time. So today we are focused on Fabric IQ. We'll put the link to the slides in the chat. You're welcome to use the slides. You're welcome to deliver the slides yourself. They're for you to use however you need. I am Pamela Fox. I am a principal cloud advocate at Microsoft and GitHub, and I specifically focus on Python and all the different ways that developers can use Python with the many, many Microsoft and GitHub tools. So APIs, SDKs, GitHub Copilot, really everything. My background is in full stack web development, so I'm very interested in how we can build applications on top of these technologies, especially these new generative AI technologies, figuring out how to build, really good scalable applications on top of them and make our users happy. So today we are covering Fabric IQ. We're going to go into multiple components of Fabric IQ. It actually encompasses a lot of technologies. So today we're going to look at ontologies, graphs, Power BI semantic models, data agents, and integration with Foundry IQ and all of those. All of the code is available in this GitHub repository, and we'll put the link for this repository in the chat so that you can get it yourself. Let me show the repo. Here we go. Here's the repo. So it has all the code that we've used throughout this entire series. It includes Jupyter notebooks, Python files, Python agents. It's got all the infrastructure as code. So it's got bicep, it's got provisioning and setup scripts. There's quite a lot in here. For Fabric IQ particularly, there's instructions here for how you can deploy all the Fabric, all the Fabric capacity and data and that stuff. So, in order to actually run this code yourself, you will need to have an Azure account. You'll need to have a Fabric license and have the ability to create Fabric items. But if you have all that, then you can use this repo to set everything up. And you can also just use the code here as inspiration for, all of your existing code projects. All right, so let's start off with actually talking briefly about Microsoft IQ, just for folks who are new to the series. So we have this Microsoft IQ platform, and the goal here is that to provide you a way to ground all of your AI LLM-powered applications, right? So we know that when we give an LLM context, that it can provide accurate answers based off that context. And that basically the better the context is that we give to LLMs, the better the results are, the more we get our domain-specific results, our personalized results, our accurate results, right? So at Microsoft, we're trying to figure out, like, okay, what is it that you need? Like, what kind of information do you need to ground your applications in order to have, great, accurate results? So we have these 4 IQs that you can use. So we've covered Work IQ, which is like all of your Microsoft 365 data, like Teams, emails, chats, documents, all of that stuff. We've got Web IQ, which is live web results. We've got Founder IQ, which is a way that you can index any sort of document. So if you have just a pile of PDFs somewhere or billions of PDFs, you can store those in Founder IQ. And then today, of course, we have Fabric IQ, and this is storing often your actual business data. You could be storing your relational data for backing your company. It oftentimes is storing your analytics data. It's very good at storing analytics data. So that's your operational, your business data. So with all of these IQs together, the goal is that you can build applications that are grounded in the results from these IQ services and are able to be highly accurate and super useful. So now we're digging into Fabric IQ. So first, let's talk about Microsoft Fabric. Microsoft Fabric is a platform for all of your data to unite it all in one place. So, before Microsoft Fabric, there were lots of different places you could have data. Azure has many different data offerings, right? So we've got Data Lake and Azure SQL and Databricks and Power BI and Azure ML, like all these different places you could have your data, and you'll have like separate storage accounts. You need to figure out how to, do ETL to do data pipelines between each one in order to, store things and mirror things and connect them all together. And it's like a big pain, right? So with Microsoft Fabric, the idea here is that you've got everything in one place. You've got a common way of accessing data across all these sources, right? So everything is in one lake, and one lake can connect to other sources and bring them together in a unified format, right? So the whole idea is to unify in one lake. And then once you have it in one lake, then you've got common things that you can run on top. So you've got data engineering, which is like your Spark notebooks and pipelines. You've got Power BI for doing like your reporting dashboards, and of course your Fabric IQ we're talking about today. And there's many different sources you can bring into one lake, right, in order to unify. And sometimes these sources you set up as like a shortcut. So you're just saying like, oh, here it is, just jump over there and link to it. Or sometimes you do mirroring. And with mirroring, sometimes we copy it in and sometimes we're just copying in the metadata and we know how to access it. So the exact way that we bring it into one lake does depend based off of what you're bringing in and also how much of it you want to bring in, whether you're bringing in just a single file from somewhere else, or if you're bringing in like the entire catalog from somewhere else. So there's all these different strategies that we can use for shortcut and mirroring. But the point is that there is a way to do it, right? So for all of these different data sources, right? So you can see obviously all of our Azure ones like Azure Postgres, Azure Cosmos, SQL Server, we can definitely bring those in, but also you can connect to Google Cloud Storage, Amazon S3, a Databricks catalog, right? Google BigQuery, that's in preview now. So many different sources that you could unify under under Fabric in one lake. So we're going to be using Fabric IQ on top of one lake, right? So we're assuming that we've brought data into one lake, and that one lake is providing a unified front to be able to access different kinds of data. So one lake can handle structured data, relational data, unstructured data, real-time data, graph data. It's able to store all of that kinds of data. So then on top of that, we have Fabric IQ. And Fabric IQ is actually many different services on top. And so we're going to explore more than half of these today. So we're going to look at ontology. We'll look at semantic model, graph, and data agent. So those first four are the ones we're going to look at today. But there's also something called the plan or planning. There's a digital twin builder, which creates this digital representation of your real world business entity. It's super interesting sounding. And then there's operations agent. So that one you definitely want to use as a complement to all of this, because it's going to be actually like it's monitoring your Fabric data to look for, kind of data issues, right? So you always want to be using operations agent. That's like your kind of DevOps for your Fabric, right? So let's dig into these four components of Fabric IQ. So we're going to start off with ontology. So an ontology is a way to describe the data that we have in our OneLake and to be able to give it a richer description so that our agents can understand it better, right? Because we can have all sorts of data in our OneLake, and really it can be quite messy to just look at that data and not know anything about it. And an agent could kind of guess like, oh, you called this this CSV is called tables, and this CSV is called products, and this CSV is called orders. So probably there's a relationship between products and orders, right? So yes, and an LLM could guess about the relations between the data that you've stuffed into your OneLake, but you're going to get much better results if you actually specifically describe it and say, hey, this is the shape of my data. These are the entities in my data. These are the relationships between those entities. This is the property of each of them, right? So this is what we do with an ontology is we describe our entities and their properties and the relationships between entities, and then we bind those to data in OneLake, right? And sometimes it's a very direct one-to-one binding where it's like obviously got the same name, but sometimes like you might have a slightly different name across different sources, and then and the binding really helps to show like, okay, this is what we mean when we say the store name, it maps to this actual data in OneLake, right? So that's the idea of ontology. So for an example ontology, if we're making an ontology for a retail store, right? So we've got entities like store. So here's our store, our store. A store holds inventory, right? So this is a relationship between two entities. So we say a store holds inventory. And then the inventory is recording the stock of a product. We also have a supplier that supplies the product, and we have a category which contains products, right? So here you can see we've got, 5 entities and 4 relationships describing them, right? And we create this ontology, and then we actually bind it to data behind it. And once we have this ontology, it becomes much easier to be able to answer questions like, hey, which store has the most number of hammers, right? And it's like, oh, okay, I'm just going to follow down this relationship and answer this question, right? So let's actually look at the ontology that I've got in Fabric, right? So here, let me go to my store ontology. Let's see. I'm going to go back. Okay. So here, this is the ontology explorer in Fabric. So you can see here's, product, and you can see that, it says category contains product. We see inventory record stock for product, and supplier supplies product. And then we can click on an individual one and we can see the data bindings, right? So you'll see here the properties. So these properties are the properties on the entity. So we're saying, hey, this product has a category, it has a description, it has a price. And then we tell it like, you're going to bind to this data source. So, we can actually go and edit the binding if we decide that it needs to bind to somewhere else. So here we can, dig into the data bindings. And here, this is the data binding, right? So in this case, it's a really straightforward data binding because most of them, I've done like a casing change, but the names in the source look similar to the property name. But a lot of times your data is a lot messier than that, right? Like I remember once dealing with some data at a company, and we had multiple user ID fields, and it wasn't obvious to me which of the user ID field was like the correct one. And I ended up making a big mistake and using the wrong user ID. And that like really, really affected the results of a query by 500,000 users. And I didn't realize that mistake till a lot later. But if I had like a proper ontology that said like, hey, this is the user ID. When we're talking about user ID, it's this ID, right? So because real data can be quite messy, and because like you'll have like, oh no, that was like the old version of the user ID. Now we're using the new version of the user ID, right? Like, so figuring out what really is the correct connection across all data, like it's really, it's really important. So you can see we've got our ontology, we've got our data binding. We can look and see, this is a nice little overview. So we can actually see get a feel for our data. So it's actually showing us like the values for category, for price. So this is actually pretty cool just to have an easy way of just getting an overview of our data. And it's just getting a feel for whether we've done this correctly. Okay. So that is an ontology, and you can create that ontology in the Fabric UI. You can also create that programmatically. So everything I've shown here, I've created programmatically just in Python. So you can see I have this create lakehouse, and in that lakehouse, I've created the ontology. So I've defined my entities, I've defined their properties, I define their bindings, and then I add relationships. So it's up to you, how you want to, work with these things, whether you want to do everything with code first, or if you want to start off in the Fabric UI, you have all of those options. All right, so we've got our ontology. So now the question is, what can we do with this ontology, right? We've built this ontology. We want to use it. So the good news is that there's a lot of agents at Microsoft that already have built-in support for ontology, right? So if you're using Copilot Studio, that should have like just a one-click add an ontology. Fabric Data Agent, we're going to see that today. Fabric Operations Agent knows about it. Foundry IQ knows about it. We're going to see that today. Foundry Hosted Agent, we talked about that on Tuesday. That one, you can add ontology in the Foundry Toolbox. So that's also just a built-in option for Foundry Toolbox. So the good news is, if you're using an agent at Microsoft, many of them already just know about Fabric IQ ontologies and have it as like a one-click thing that you can just add into there, which is really cool. However, there's also just generically an MCP server. And an MCP server is great because you can just point any agent as an MCP server as long as you can handle, passing in the right authorization. So we're actually going to start with looking at that ontology MCP server, because it's also the ontology MCP server is what a lot of those agents use behind the scenes, right? So this is, if you were going to build your own agent on top of it, you would use this ontology MCP server. So basically, we construct this URL for the MCP server, right? It's at this MCP URL for the our workspace ID, and then our ontology ID. So every ontology will have its own specific MCP URL. So you could actually be running multiple ontology MCP servers. And then it has two different tools that it exposes. So the first tool is list ontology entity types. So that just shows you what are all the entities in this ontology, and that helps give the agent some information about how it can explore it. But then there's also search ontology. So that you can just pass a natural language query in, and you'll get back results, and you can even get back a full answer too. So you can actually say whether you want a full answer, true or false, and then it'll use its own LLM to even answer your question, right? So we're going to go ahead and play with that and see that in this notebook here. Let me go open it up. Oh, here we go. Oh, no, I want my other one. Boop. This one. Here we go. All right. So the first thing we're doing is I'm using the just official MCP SDK to create an MCP client so that I can interact with it. And I've got my MCP URL stored in my .env file. So I set up a client that connects to that MCP URL. And it is passing in my token. So I'm using the credential for my Fabric tenant, and it is passing in that as an OAuth bearer token, right? So Fabric IQ, it's based off of the user's access to Fabric, right? So I'm able to access this Fabric ontology because I have permission to this Fabric ontology workspace. Somebody else may not have permission for it. So this is based off of, does the user have permission to access this Fabric workspace? So we have that listed, and then we list the available tools. So we're just saying, hey, MCP server. So an MCP server, if you haven't used MCP, is a standard way that servers can expose tools for agents to use. So we can ask the server, hey, what tools do you have that I can use? So it says back like, oh, I've got this list ontology entity types. Here's the description of it. Here is the parameters that it takes. So it's looking for an entity name. If you want to pass it in, that's optional. Whether to include properties, right? So that's really our kind of an ontology discovery mechanism. And then the more interesting one is search ontology, because that is going to take in a natural language question, and then it can even give back a natural language response if we want it. Otherwise, it'll give just the results. So here I'm going to use that one, and I'm going to pass in this question: which products currently have the lowest inventory quantities? And that should be answerable from the ontology, because we have the product, inventory, and all those relationships. And then I'm going to say I do want the natural language response, right? And that does mean that this is going to take longer. This was actually pretty fast. This was 18 seconds, but generally, like, just anytime you're going to get back a natural language response, that's going to take longer because that does use an LLM. So here you can see we get back a basically like flattened data. So there's two things that comes back. There's this raw, and then at the very bottom, there's this natural language response. And so we can take a look at this first, right? So we get back this response that says, oh, here's the products with the lowest available inventory, inventory, and here's all the information, right? So sometimes that's all we need as a response, but we also get access to this raw data that comes back. And, it basically chooses what data it's going to send back that it thinks you want. And in this case, it basically flattened a lot of data. So it gave me back like the full product JSON, as well as SKU and name separately. And then it gave back like full inventory JSON and then ID and quantity, right? So it's kind of flattening back the results in a way that it can pass it all like this. So there we go. So we can get, really useful responses from the ontology. And so you could point, you can point any agent at this ontology MCP server as long as you can send in the right authorization. So I actually have it added to my GitHub Copilot. So here in VS Code, I've configured a global MCP configuration to know about this Fabric ontology MCP server. And so that's using the same URL as before. And you can see that it found that there's two tools. And so I can open up my Copilot here, and I can see the tools, and I can see them listed here. And so I can actually just ask the question here, like, what, let me see, what was the question we asked here? I'll just take the same question here and put it in here. So the hope is that it's going to realize that the ontology server is going to be the way to answer it. And it decided that it's going to first list the ontology entity types. And now it's doing search ontology. Oh, and it's gotten really fancy. So in this case, because it first looked at the ontology, now it knows a lot. So now it's like giving like this super specific query, which is quite interesting. Every time you use an agent with an MCP server, you're going to get different results, because every agent, every model has, every agent harness, every model has a different approach they're going to use to tool calling. So, this is GPT-5.6 Sol on Medium. So this is what it decided to do this time. Previous times, it's done something different. So, there's always going to be variability when you're using agents with MCP servers in terms of which tools they choose to call, which order they do it in, and what arguments they decide to pass in. So you see, we can get back the result. We can look and see, this is this is what we saw before, raw fields. And then we also got the natural language response. And it decided to ask for the natural language response. And then we got the actual summary in VS Code here. So there we go. So we can use it from a lot of sources. You can use it from VS Code. You can use it from the Copilot CLI. You can use it from the Copilot app. Now, so it works in all of these, GitHub Copilot instances. Unfortunately, I don't think it would work in something like a client like Claude. And that's because of the authorization. It works in clients that are pre-authorized with Microsoft Entra, like all of these, official Microsoft ones. I don't think it would work with a client like Claude because of just how MCP auth works and not having pre-authorization. So that's just a warning that if you do try it outside of these three places, you may find that the authorization doesn't work, and you may have to like set up like an Entra client ID and all this stuff. So it's great that it works all these places, because these are all my favorite places to, you know, I love GitHub Copilot, and that's what I use. So it's great that it works so well with our offerings. But just because of the complexity of MCP auth, you may have some issues if you try to use it in an arbitrary MCP client. All right, so now let's talk about integration with Foundry IQ. So we talked about Foundry IQ on Tuesday. So as a reminder, with Foundry IQ, we can set up these knowledge bases that have multiple sources, and then we can do searches across these multiple sources and get merged results from them. Now, one of these sources can be a Fabric IQ ontology. And so that's treated as a remote knowledge source, where it's actually going to use that like MCP server behind the scenes, send the query to it, get back the results, and merge them with the other results. So, you know, what's going to happen is we get our question, it goes off to the ontology queries the lakehouse, we get back the results, and those results gets merged with the rest of them. So let's actually look at the code for that, right? So here we've got another notebook. So we set up, you know, everything we need to connect everything. We get a token. So once again, you know, for this, we do need a token that has access to the Fabric workspace. That could be different from the token that has access to the search service. So there may be two tokens involved. And in fact, in my case, there are two tokens involved, right? I have the search service on a different tenant than the Fabric tenant. So I'm using, in this case, I'm using a key credential for the search service, but that is on a different tenant. And for the Fabric service, I'm making sure that I'm getting a token for me in that tenant, because that's, you know, who has permission to it. So when we're adding this, you know, remote Fabric knowledge source, we do need a way of getting a token for the person that has access to that Fabric tenant and that Fabric workspace. Then we are using the Azure Search Python SDK to set up knowledge sources. So we can set up some just normal index knowledge sources, but then we can set our Fabric ontology knowledge source. So we say, okay, this is our Fabric ontology knowledge source. Here's our parameters. Here's the workspace ID, and here's the ontology ID. And then we can also give it some more information that will help it decide when it's going to use this knowledge source, right? Because when we're setting up these knowledge bases, we have multiple knowledge sources. We want to make sure it's clear what questions should go to this source, right? So I've specifically told it that it has product data. And I could get much more descriptive there and say, oh, it's got like inventory and stock and all of that stuff, right? And then we're going to set up the knowledge base. So we say like, okay, you know, you're going to create a knowledge base with all those knowledge sources. And I even give it additional instructions here. So these are my retrieval instructions. And I said, hey, use Fabric ontology for structured operational data, use a search index for HR and policy documents, right? So you can, you know, give it lots of information to help it choose the right source to use. So then I gave it a question. So which product categories currently have the lowest stocks sales? And we can see that it got back the responses. And this all came from the product ontology. This is from like category combined with inventory and stock levels. And then we can check the activity log, and we can see that it did send a query to the ontology. And it actually decided in this case, because part of what the knowledge base does is decide which sources to send to, it did not send this question to our other search indexes at all, because it said, hey, this is a product question. I only have to send this to ontology, right? So that's one of the nice things about the knowledge bases, is that it has this source selection built in. So we can look at the question and say like, listen, I only have to, in order to answer this question, I only have to send it to one of these sources. I'm not going to waste my time with the other sources. So in this case, it only sent it to the ontology and not to any of the other sources. And so then we can also look at the references, and we can see back everything that came back. And so that's how it answered the question, was based off of all this data that came back. So we can see that raw data, which we saw before, and that answer. All right, so there we go. So that's integration with Foundry IQ. So as I was saying, ontology does integrate with many places. So if you are, you know, deploying a Foundry agent, you should also be able to add an ontology there. I saw a question about Teams. You should be able to then publish your Foundry hosted agents teams, and then be able to use Fabric. But just keep in mind that the person authenticating would need to have access to that Fabric tenant. So that may not always be what you expect. So you just have to think about whether that's the way you want to set it up. All right, let's talk about graph now. So, and graph is going to look similar to ontology. Ontology actually has uses graph for its querying. So that's what's interesting. But graph is an offering in Fabric IQ, in Fabric, when you really, really want the advantages of graph querying and graph database. So if you're doing queries that are really, really reliant on being able to do traversal in a graph, then you can choose to explicitly set up a Fabric graph in order to store that data in the most efficient manner, right? So if you're doing lots and lots of queries that require these graph traversals, then you may choose to store data in graph in order to really optimize those queries. So that's how I would think of the Fabric graphs. It's just a little confusing between ontology and graph, because I think you'll be looking at this and thinking like, wait a second, like nodes and edges, entities and relationships, those are very similar. And there's definitely an overlap in between them. But I would say, you want to use graphs when, if you're thinking about like something you would normally use a graph database for. So when you're really going to doing a lot of graph querying, that's when graph would make sense. So what we do is we set up nodes and edges. So the nodes are the things and the edges are the relationships, right? And then, we've got labels for nodes and then properties for them. So this is similar to like ontology with entities and relationships, but we're using graph terminology here in order to describe everything. So once we set up the graph, we also need to bind it to some data, right? So similar to how we did data bindings before, we're going to set up some source data and say like, hey, this is our source data. It's one lake. It's got like these lake house tables. And we say, this is how we're gonna map this, right? And so like the edges will actually like have their own table. So like this one, like review feature mentions, like that would actually be a table in Lakehouse, and that becomes an edge over here, right? So we have our source data, and then we map it, and it becomes a queryable graph, and that graph is optimized for very fast traversal and very fast graph queries. So I have a graph that I set up in Fabric UI. So here I'm using it for product reviews. So imagine, I've got a website for all these products. So each product has a review. A reviewer wrote the review. Each, review can mention features, right? So we can see like, oh, does this review mention, a particular feature of a product? So we can see, who's talking, positive or negative about some, particular feature of a product. So that's our graph set up here. And this is, our little graph explorer. And you can, dig in more to them, like to each individual one. So here you can see with product, we have a source table for it. And we map the labels to the source columns, right? And then if we click on the edge, same thing is that the edge has a source table, and it needs to know like how to go get from the origin to the target. So we say, oh, the origin node is product SKU, and the target node is review ID. So it's doing this mapping between nodes and edges. So we set up all these edges and nodes. So now we've got our graph. And once again, I did all of this in, I created all of this in Python. But you can do this all in the UI as well, however you want to do it. So we have our graph now. Now we can use GQL. And GQL is a graph query language. It's not the same as GraphQL. So I keep on accidentally saying that instead, but it is GQL. So GQL is this language for querying the graphs. And, it specifically has this syntax for identifying nodes to edges. So you can see here, it's like, This GQL query is saying, okay, Matt, follow the product, has review mentions features. So this is basically like doing a little graph traversal here with the, you can follow, it's going node to edge to node to edge to node here. And then we can add on, filters. So here we're saying, okay, filter where the sentiment is negative, and then you're going to return all this stuff here. So you can create these GQL queries, and that can query the graph, and then you can then execute those GQL queries. So you can execute in the Fabric UI, or you can execute them over the REST API. So let's go ahead and use the REST API. So here we are, setting everything up, and we've got the GQL endpoint. So, here we're specifying our workspace ID and our graph ID, and that gives us our URL for the sending the GQL queries. Then we have our actual GQL query. And the goal of this query is to find negative feature mentions connected to product reviews. So we want to see where our products aren't doing as well. And then we get a token for our Fabric tenant. Once again, it needs to be for us that has access to the Fabric tenant, Fabric workspace. And then we get back the response. So here in the response, we can see we get back a table with columns, and then we get back the actual data, right? So this is the data that it sent back. So basically, this is everything we asked it to return. See, we asked it to return all this. So we get back all of that in a single table, and it's combined all this information together for us, so we can see, oh, okay, it's saying that the weight of this. Okay, so then I guess they're saying the weight is negative, right? Battery life is negative. Okay, so it's a negative review about battery life for this for this product here, right? So we get back all the results. And so you'll notice we only get back data results, right? So this GraphQL is purely doing a data query. It's, so there's no LLM involved here, right? Because, we're just sending in a graph GQL query, and we're getting back data. So this was actually quite fast. You can see this was 2 seconds to execute that. That's pretty fast. And, it's able to do that very quickly because there's no LLM involved. We're just sending in a query. We're getting back results. So how would we then query this from agents? So generally, if you wanted to query this from agents, you would want the agent to be able to create the GQL. And luckily, GQL is, this particular GQL is specific to Fabric, but it's also generic too. Like there's kind of like this generic standard around it. So the agents are pretty good at constructing GQL, especially if you kind of give them some tips about how to do it. So you could create your own tool that, says like, hey, I need a GQL. And then you could, do what I just did, is then just call that graph API behind the scenes. So that would be one way that you could do it. Or you can add it as a data source to Fabric Data Agent. So that's what we're going to be doing later today when we see Fabric Data Agent, is just adding this as a data source. So that's what most people will do, is just add it as a source to Fabric Data Agent. But you could always make your own tool, right? For any, you can basically for anything in life, anything you can programmatically, access, you could make your own tool for, right? And you just have to figure out what is, arguments is your tool going to have, and what is it going to return back? And then you just make this API call behind the scenes. All right, so now let's talk about semantic models. So these semantic models, these come from Power BI. For those of you familiar with Power BI, these are the Power BI semantic models. I'm actually not that familiar with Power BI, so this was my first real introduction to it. But these are really optimized for aggregation and reporting, especially like analytics reporting, right? So I have used many Power BI reports from other people, and it's always for analytics. It's like, how are our GitHub repos doing? How many deployments are we seeing, right? Like, how have we done in the last month? And you're always like slice and dicing, let's slice it by repo, let's slice it by month, right? So these are all optimized for reporting. So in semantic models, you have tables, you have relationships between tables, you have the measures, which are like the calculations that are being done on these tables. And then you have the data source, which is, the data binding, which is binding it to the one lake, right? So we set up everything up, and then we make a Power BI report that can query all of that. Now, when we describe our data, we use something called a star schema. And you see here, I made a diagram that looks roughly like a star. And in this star schema, there are facts and there are dimensions. So the fact, those are the rows that are going to be aggregated. A lot of times these are events. So I find it the most useful to think about it as events. So a page view would be a fact, right? Because page views happen constantly, right? Like, thousands of people an hour are like, doing page views, right? So that would be a fact. And then the dimensions, those are the things that you want to be grouping or filtering by. So you can think like, oh, for a page view, what country did that person come from? What browser were they using? Those would be a dimension to those facts, right? So that's how I think of the difference between facts and dimensions. So whatever it is you're going to be reporting on, you want to come up with a schema of facts and dimensions so that you have really good performant reports. So we can define those semantic models using this format called TMDL. And I have TMDL in the repo. So this is all just from the repo here. So you can see we can have a TMDL file for a fact table and then a TMDL for a dimension table. So for sessions, we say, okay, we're doing a session and and then we do the data binding. We say, oh, coming from our lake house, and it's coming from this table in the lake house, right? And then we can add measures to those fact tables, right? So here we have a measure and it's doing this calculation, and this is called a DAX calculation, which is basically like Excel, but even better, or like Excel formulas, but more. So here, we have these calculations here. So we define that all in the fact table. And then we have the dimension table. And similarly, we define these dimensions, and then we need to bind them to a lake house entity. So then once we have all these defined, then we can create semantic models based off of these facts and dimension TMDL files. So now let's go and explore the semantic models that I've created. First here we can see these are what we're binding to. So saying we do have these lakehouse tables here, and these are what our kind of dimensions look like. This is what our sessions look like. So you can see there's a lot of sessions, and they just basically have lots of keys out to the dimensions, right? So the session rows are quite short because everything here is really a key, so that then we can look it up in the dimension tables here, right? So then we create the semantic models on top of them. Where's our models? I have to remember where to actually even find the models. Okay. Semantic models. Let's see. Wait, let me see if I just have it in my .env. A lot of times I just write out the semantic model UI. Okay, great. Let me check this one. Ting, ting, ting. This might be our lake house again. Let's see. Oh, there we go. Yeah, this is what I wanted. Okay. All right. So this is how we can explore the semantic models. So we can see like sessions, and you see the epsilon, that E next to it, and that indicates a calculation. So all of these are DAX calculations, right? And then we've got the actual things that are being stored in that lakehouse table. And then we've got our dimensions here, and you can see how things are connected, and it looks roughly like a star. So we've got that all set up now. And once we have the semantic models and the binding, then we can create a Power BI report. And a report is like the whole dashboard. And inside a report, you have pages. And inside each page, you have visuals and you have filters. So once again, you can define all this in code, actually using a JSON format. So I've got a bunch of JSON in the repo that defines the parts of this report. And then I can create that report, putting together all those different components. So then going over here, I've got my dashboard. So this, you can see, this is a page in the dashboard, And we've got these cards up here that are just showing, just simple numbers. We've got filters on the side here, so we can look at date. We've got charts here. So these are nice visuals that are charts. And yeah, we can see how the filters are, affecting everything here. So there's our report. Okay. So that's cool. So that's like, how would you even set up Power BI programmatically, which is helpful. Now maybe my colleagues will ask me to make Power BI reports, so don't tell them I know about Power BI now. And now the question is, okay, we've got this semantic model set up, we've got the reports and people like the reports, but we want to be able to programmatically query those semantic models from our agents so that we don't have to be going to the reports to answer all the questions. So for that, what we need to do is create DAX queries, right? So the DAX queries, I'm saying that's kind of looks like an Excel formula, but it has some additional features. Like here you can see like order by, right? So we need to be able to construct DAX queries, and then we can send those DAX queries to the semantic models. So that means we need something that can do natural language to DAX. Now, Fabric Data Agent, once again, already has support for natural language to DAX. It knows how to do it. You can also try building your own our agents and having it do that NL to DAX. DAX is specific to Microsoft, so it may be it might have a harder time with it, but also the models do know Microsoft stuff pretty well. So even if it is like specific to Microsoft, I think they can do a pretty good job at it. There is some prep work you can do. So there's a whole documentation here about how to make your semantic models be the most, agent friendly, like so that they're the most, it has the greatest success at doing that NL to DAX formulation. So most of the time, you're probably just going to add it as a data source to a Fabric Data Agent and use it that way. But if you wanted to, you could also make your own agent with a custom tool that basically did NL to DAX. All right, so that finally brings us to Data Agent. So Fabric Data Agent is a conversational agent that can query across multiple Fabric data sources. And this is kind of similar to the, knowledge bases we were talking about before, right? The ability to query across multiple Fabric data sources. So it's going to take in a question. It's going to validate that the question is like a valid question, that's not violating any sort of like policies or PII issues that you might have enforced, that syntactically that it makes sense. Then it's going to do source selection. So it's going to decide which of these sources is going to use to answer the question. I believe it can only use one source at a time. This is something that I need to get confirmation of, but in my experience, it's only selected one source at a time. So I think currently it's figuring out which of these is going to answer it versus like sending it to multiple at once. So it's going to select one of those sources. It's going to generate the query for those sources. Now, each of these understands a different sort of language, right? So semantic model, that's going to be DAX. If it was Lakehouse Direct, SQL. If it's Event House, KQL. If it's the graph model, GQL. If it's Data Warehouse, SQL, right? Now, luckily, these models can construct all of those kinds of languages, but it is going to depend on the data source, what sort of query it forms. Then once we've set up the data agent, we can use that data agent as an MCP server. So we have a URL for the data agent, and that data agent MCP server exposes a tool just for that agent that can take in the question and give back the results. So let's check out how that works. Okay, so here we go. So this is similar to before. We are just creating an MCP client that is pointing at that MCP URL. Then we say, hey, MCP server, what tools do you have? And you can see it has a single tool, and it's actually named custom based off of what I call that data agent. So it says, okay, this is the Contoso DIY data agent. Contoso is my pretend store. It also has a description, and the description was entirely based off of what I told it. So here you can actually control tool and description. That can be really helpful because if you have multiple data agents, you want to disambiguate, right? So this helps with disambiguation. And then we can see that this tool takes a single argument, which is the user question. Then we can query it. So we can try querying multiple sources. So this first question I have here, this is one that would be answered by the ontology. And I've added that ontology as a data source to this data agent. So it should be able to answer this question because it has access to the ontology. So we can see that it does get back an answer, and it gives me all this back. And what's really cool, it gives you this deep link URL in the results as well. And this opens up this Fabric UI, which gives you more details on the query. So we can see here's the query, and then we can see what it actually did. So we can see that the way it answered this query is it actually came up with GQL. So the way it does ontologies is it does come up with a GQL query. So it came up with this GQL, and it ran that GQL. And then we get more data here. So here we can actually see it said, oh, the result was incomplete. So you definitely want to be checking out this, when you're developing your data agent, like you do want to be clicking through and looking at this, this process here to see, if it's working the way you expect or if there's anything you need to improve. Now we can also ask a question that would query that Power BI model, right? So, what is the total website revenue and conversion rate? That answer is only in the semantic models. And we can see that it got back an answer. And once again, we can open that in Fabric. All right, and we'll look at this thing here. And in this case, it did a DAX query, right? So it came up with this DAX here. And this was a pretty simple DAX because the data was already directly in there. And then we also get back the more natural language response here. So there we go. So you can add all of these multiple data sources to your data agent and then be able to get back responses for it. Now, since it's an MCP server, once again, we can access that from our GitHub Copilot clients. So I added it to GitHub Copilot app. So if you look at my MCP servers, you can see that I added this MCP server here and, just as HTTP. And when I added it, it prompted my login because it needs my auth token. And I had to log in to the account that had the Fabric server in it, right? And then I could ask the same question and we can see the user question it decided to use. We can see back the answer, and we can see that deep link URL so that we could debug it, right? We could also just see what my Copilot model decided to respond to with and just see that answer there. So that's really cool that we can use this data agent from multiple sources. Now, we can also use it from Foundry IQ knowledge base, right? So going back to Foundry IQ knowledge bases, one of the knowledge sources you can add is a Fabric data agent knowledge source. And so that one, we're adding like another level. So basically what we did before, but we're adding another level. So this time, if we're adding a Fabric data agent, that Fabric data agent is going to receive the query and it's going to decide whether to send it to an ontology, a graph, or semantic models, right? So if it decides to send it the ontology, then, we go back down that ontology route. So this is definitely adding another, we're adding another agent in this flow. And you really want to consider carefully if you do want to set up this sort of flow. For example, if all you have was ontology, you would certainly want to just directly add ontology as a knowledge source, right? You don't want to have this data agent in the way. The data agent is the most useful when you've got these multiple sources and, especially beyond ontology, and you want to be able to just arbitrarily handle any of them. But we can add this data agent if that's helpful. So then we can go and check out what that looks like. We set up our connection, we get the token for our Fabric tenant. Then this time when we create the knowledge source, we're creating a Fabric data agent knowledge source. So we give it our Fabric workspace ID and our data agent ID, and we tell it what sort of information it has access to. Then we create the multi-source knowledge base. And this time in the retrieval instruction, I said, use the Fabric data for structured product inventory and analytical questions. So trying to give it a good idea of when it's going to use that data agent and when it's going to use the other indexes. So in this case, I'm sending it a complex question, actually. So I said, which products or product categories have the lowest inventory right now? And I also asked which Contoso job roles are responsible for inventory strategy. So this actually can only be answered by these search indexes. And this is the question that can be answered by the data agent. So we get back an answer, and all of this information here all came from the data agent, from the ontology underneath it. And then all this information here came from these search indexes, right? And then it, tries to come up with an answer based off of all the information it sees across that. And then we can look and see what it did. So we can see, okay, the knowledge base, it decided to send this query to the index. It sent a couple different queries to the index. And then this is what it, for the data agent, it just directly sends the full question and lets the data agent decide what to do with it. And then we can look at the references, and in the references, we can see what came back from each of the sources. So I'm just looking for the data agent here. Data agent might be at the bottom. Okay, let's see. Okay, there we go. So here's the Fabric answer. And you can see it's very long. There we go. So got back that answer there. All right. Okay. So there you can see integration with Foundry IQ. Once again, you could also integrate with Foundry hosted agents and add the Fabric data agent to a Foundry toolbox. And as long as the user was authenticating that had access to Fabric, they'd be able to access it there. So lots of different ways that you can integrate with data agent. I saw there's a question about the deep link URL. So that is just literally, it's coming back as a result from the MCP server. So the MCP server is returning both structured content. So this is the structured content, which is basically JSON, being rendered as JSON here, and then free text content. In the structured content is where the deep link URL is, and then in the free text content is where you get the actual answer, right? So here you can see, result.content is where I get the natural language response, and then result.structured content is where I get the deep link URL. Now, since we're talking about it, I will admit that there is an open issue in VS Code where it ignored, if you have both, here we go, here's the issue. If you have both, if an MCP server returns both structured content and content, it's actually not showing the content to the agent. So that is why I did that data agent demo in Copilot app. Because VS Code does have this open issue where it's confused about the mixed use of structured content. And this part of this is just because MCP is a newish protocol. We're still trying to figure out how clients could respond to it. And so it was unclear, if a call to a result has both content and structured content, how should that be presented to the LLM, right? Should the LLM see both of those? Should it only see one of them? So I've pinged this to the VS Code team and said, hey, this is affecting, one of our MCP servers. So so hopefully that'll be resolved soon. But yeah, that is why with the Fabric Data Agent MCP, we get back both this free text response and the structured response here that has that deep link URL. All right. Okay, so now we're reaching the end of our series. We've tried to cover a lot of aspects of the current Microsoft IQ platform. It is evolving all the time as we figure out, what people need in order to, build the most powerful and accurate applications with LLMs. But we've seen Work IQ, we've seen Fabric IQ, we've seen Web IQ on the first day with Foundry IQ, and then of course Foundry IQ. And all of these IQs can interact with each other. So, Foundry IQ can actually consume Web IQ, Fabric IQ, and Work IQ. So if you want, you can actually use Foundry IQ as your one IQ to rule them all and have it be a multi-source knowledge base for everything else. Or you can use these things, separately of each other, right? So you need to figure out what are the situations that you're solving for? What are you building? What do you need access to? What sort of do you want to go through an agent? Do you want just directly the structured results? What's the sort of latency concerns that you have? Because a lot of these do have their own built-in LLMs that can do query planning and answering all that stuff. But anytime you have a built-in LLM, that does add latency, right? So hopefully you've seen a lot of options over the course of this series, and you can start experimenting those options and start setting up evaluations. We didn't have time to talk about evaluations in this series, but I've talked about that in previous live streams. It's so important to set up evaluations. Foundry has a really nice evaluation platform now. You really need to set up evaluations so to represent all the different queries that you think you're going to be handling and seeing what results you're getting back. Are they accurate? Are they fast enough? And figure out what solution you're going to use to power your applications. We are going to be having a bi-weekly Microsoft Reactor series on YouTube starting August 6th. So if you want to continue your Microsoft IQ journey, this is being organized by Aicha. So you can register for that at this ACA that we'll put in the link, Microsoft IQ Live. And so that way you can keep up to date with everything happening with Microsoft IQ. It's definitely evolving all the time. So you should keep watching and seeing as we improve it and develop more services based on what all of you need. So for today, the stream is over, but we do have office hours. So if you have additional questions, please come to office hours. I've asked our Fabric data advocates to join in the office hours and share their expertise. I'm actually quite new to Fabric. This is my first time talking about Fabric. So thanks all of you for giving me excuse to talk about it. But we do have Fabric data advocates that are going to be bringing their expertise to the Discord. So please jump into the Discord. We're putting the link in the chat. We've got it in the chat already. So you can come into the Discord and ask any of your additional questions about Fabric in the Discord. All right. And yeah, that is what we have for you. I'll head over to the Discord. And thanks everybody for joining the series and bringing your enthusiasm and your questions. See you in Discord. Bye.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.